Hello and welcome. We're going to take a look at another application of vectors. So this will be one application of cross product, more specifically the torque. Remember, torque is the measure of the turning effect of a force when the force applied causes an angular displacement about a certain point. So you can think of the torque as the measure of turning effects of a door. So when you open and close the door. So is it easier to open or close the door if you use the handle on the edge of the door, or if you just push the door here close to the hinge? So the magnitude of the turning effect is called the torque, and it depends on the value of r. Value of r is the distance from the axis of rotation and the force applied. So this would be the cross product of the two, which is also described as the magnitude of r, magnitude of f, sine theta times the unit vector n. Remember, torque is a vector quantity because it's given as the cross product of two vectors, which is another vector quantity. Now, F is the applied force. Remember, R is the vector determined by the lever arm acting from the axis of rotation. So what that means is that when we measure the value of R, we measure it away from the axis of rotation. So the vector of R will go this way around. And theta is the angle between the force and R. And last, n is a unit vector perpendicular to both r and f. So let's take a look at our first example. So we have a right threaded bolt that is tightened by a 50 Newton force to a 0.2 meter wrench. The torque about the center of the bolt then will be given as magnitude of the force and magnitude of r, and multiply this by the sine theta. So since we're finding just the magnitude of it, so we're not going to consider the unit vector, or we can just replace it by 1 in this case. So the force is 50 newtons as described, and the value of r is 0.2. And now let's talk about the angle theta. So when you are tightening the bolt, the angle made between the force applied and the wrench will be 90 degrees. So that would be a sine of 90. So sine of 90 equals 1, which will make the torque equal to 50 times 0.2, or simply said, just 10. Now let's think about the unit measurements of the torque. Remember, you're multiplying newtons with meters, so that would be described as Newton meters. So that's the answer for the first question. So here we have another example. So I suggest you try this on your own. Here I go. I'm going to explain it to you. We have to find the torque produced by a cyclist exerting a force of 115 newtons on a pedal in the position shown in the diagram. Now the shaft of the pedal is 16 centimeters long. So you understand that this is probably going to give us the value of r, because we're applying the force right on the shaft of the pedal, so that on the pedal, and the shaft is only 16, so that will make r equal to 16 centimeters. It is very important we convert this to meters, so that would be 0.16 meters. Now the force given in this case is 115 newtons. It is very important now to find the angle theta made between the force and the length of the arm. So let's take a look at the diagram here. So what we have in here is the force. It is heading in this direction, and this would be the value of r. Now the angle made between the force and r, so f and r here, will be found by placing them tail to tail. So what that means is I'm going to extend the vector that represents r, and I will bring the vector that represents the force f right here. So let's look at all the angles formed. I'm going to draw a horizontal line that will help me kind of figure out what angles are formed in here. So as you can see, we have an angle 25 that will make this angle equal to 25 as well. In the meantime, we have this angle 15 degrees. So vertical and horizontal make an angle of 90. So that means that the angle between the head of the force, and this horizontal would be 90 minus 15, or 75 degrees. So far we have 15, we have 75, 25, and we are interested in knowing what the angle between R and F is. So this angle right here. I will highlight this so that we can see it better. And we'll say that since the force has been just translated here, that's a 180 degree angle. We have 75 plus 25. That makes 100 degrees. And that will make the angle between R and the force 80 degrees. So now that we know the angle made between the force and R, so that would be 80 degrees, then we can use the formula for the torque to find the torque. So torque would be equal to magnitude of the force, magnitude of R, sine of angle 80, times the unit vector n, which is 115, times 0.16, times sine 80, 80 degrees. So calculate it, times 0.16, sine of 80. So I got 18.1. So 18.1 Newton meters. So that would be the torque in this case, and it will follow the direction perpendicular to both R and F. So that was it, and I hope this made sense. Thanks for watching.